This question gives an equation for a reaction, but it says that this reaction can't occur because it violates two conservation laws. And it asks us to find out which two conservation laws are violated, in other words, which laws aren't obeyed. So things we should be thinking of for conservation laws when we're dealing with particles, we should be thinking about charge, we should be thinking about baryon number, we should be thinking about lepton number. So let's have a go. Let's think about the charge. A proton's got a charge of +1. Going to the right hand side, an antineutron, got no charge, just like a neutron. An antineutrino, got no charge. But this is a positron, has got a charge of +1. So +1 on the left, +1 on the right, so the charge law is obeyed. So let's try another law. Let's try the baryon number law. So for baryon number, is a proton a baryon? Yes, it is. So what's its baryon number? It's +1. Is a neutron a baryon? Yes. So what about an antineutron? An antineutron must be an antibaryon. So what's the baryon number of an antineutron? It must be -1. Is a positron a baryon? Well, a positron belongs to the same family as the electron. It's not a baryon at all, so it's got a baryon number of 0. And the antineutrino, that's not a baryon at all. That's got a baryon number of 0. So in the equation we've got +1 on the left, we've got -1 and two zeros on the right. So baryon number isn't conserved. So that's one of the reasons why this equation can't happen. So the first law that's violated, conservation of baryon number. What else have we got to try? What about lepton number? Is a proton a lepton? Can't be, we just said it was a baryon, so its lepton number is 0. Is the antineutron a lepton? No, we've just said it's an antibaryon, not a lepton at all. What about the positron? Well, the positron, like the electron, they belong to the lepton family, but the positron is an antiparticle, so it must be an antilepton, lepton number of -1. The other thing in the equation is an antineutrino. That's also an antilepton, also got a lepton number of -1. So in this equation, the left hand side lepton number of 0, the right hand side lepton number of -2. So the conservation law isn't obeyed, which is why the equation can't happen. So the second conservation law we're going to put is lepton number. That's not conserved. So the next thing to write, give the correct equation of positron emission. And that's something we have to remember, really. In positron emission, you start with a proton, which is positive. The proton turns into a neutron, not an antineutron, just an ordinary neutron. And as well as the proton turning into a neutron, that means it's lost some positive charge. The positive charge is lost because there's a positron emitted. So there's the charge taken care of. The baryon number is taken care of. That's a baryon and that's a baryon. What isn't taken care of is at the moment we've got an antilepton with a lepton number of -1, but to make the equation balance we need something with a lepton number of +1, and that's going to be an electron neutrino. So there's the equation. The last part, draw a Feynman diagram in terms of quarks to represent positron emission. So what we're showing a proton turning into a neutron. If you think about the quarks, a proton, you can either remember, if you can't remember it, let's look at the table and work out that a proton consists of up, up, down. It turns into a neutron, and a neutron is up, down, down. So when a proton turns into a neutron, what actually happens, that stays the same, that stays the same, and up turns into a down. So if our Feynman diagram is showing the change, you're starting with an up quark, that up quark becomes a down quark. What happened as it was becoming a down quark? Well, it must have emitted an exchange particle. Now we know that when quarks change from one quark to another, different sort, it's all to do with the weak interaction. So this is going to be a W boson. And what do we get on the other side? Well, we've got a positron. And we've also got the electron neutrino. So what's this boson doing? It's removing positive charge from the left hand side and taking it to the right hand side. So therefore that's going to be a W plus.